Last session we will discuss that when you are consider purely resistive circuit, voltage and current both are in phase. So this VR is always in phase with current. So phase angle from the reference is 0 for VR. And when you are considering purely inductor circuit, current is always lagging behind the voltage by 90 degree, that we are discussing last session. So this is vector VL and the angle from the reference axis to the VL is 90 degree. We are consider current as a reference, so this VR is at a reference axis and angle from the reference axis to VL is 90 degree. So this is the phasor representation of VR and VL. And if you have to find the total voltage, to draw the parallelogram, one line parallel to VL, second line parallel to VR, and draw the resultant. So this VT will give you the value of resultant voltage, which is equal to under root of VR square plus VL square. Now the total voltage in a series RL circuit is given by this equation from this phasor diagram. VT is equal to under root of VL square plus VR square, where VT is the total resultant voltage and VR is the voltage across resistance, VL is the voltage across inductor. Now one example, you have to find the reactance and impedance for a given circuit. Circuit is given like this. One resistance is given, value of resistance is 12 ohm, inductor is given, value is 100 millihenry, and voltage applied to given circuit is 100 volt and frequency of the supply is 50 hertz. You have to find the reactance and impedance of the circuit. Okay, equation of reactance is known to you, which is equal to XL, which is equal to 2 pi FL. Frequency is 50 hertz, inductance is 100 millihenry, so your reactance is 31.4 ohm. Now equation of impedance is also known to you, which is equal to R plus JXL. Value of resistance is given to you, value of XL is known. So Z is equal to 12, which is your resistance, plus J 31.4, which is your reactance. So reactance of the circuit is 31.4 ohm and impedance of the circuit is 12 plus J 31.4. Now second example, take this circuit as an example to work with a given figure, and figure given to you is like this. Resistance and inductor is connected in series. Value of resistance is 5 ohm, value of inductor is 10 millihenry, and supplied voltage is 10 volt and frequency of the supply is 60 hertz. And you have to find the total voltage, resultant voltage, voltage across resistance and voltage across inductor. Okay, so first of all you have to find the total impedance, Z total, which is equal to R plus JXL. So resistance is given, which is 5 ohm plus 3.76, which is inductive reactance. So your Z is equal to 5 plus 3.76, which is your XL. So your Z total is equal to 5 angle 0, because it is real part. So angle for the real part is 0, so 5 angle 0 plus 3.76 angle 90, because it is imaginary part. So angle of the imaginary part is 90 degree, or you can rewrite like this, it is 5 plus J0, J0 means imaginary part is 0, plus 0 plus J 3.76, 0 means real part of this particular portion is 0, because it is on a y axis. So it is 0 plus J 3.76 ohm. So your finally answer of Z is equal to 5 plus J 3.76 ohm, or in polar form it is 6.26 angle 37.016. Now Ohm's law for AC circuit. Ohm's law for DC circuit is V is equal to IR. If you have to apply the Ohm's law for AC circuit, instead of resistance you have to consider the effect of impedance. So for AC circuit, Ohm's law is like this, E is equal to I into Z. So I is equal to E by Z. So Z is equal to E by I. Now value of impedance is already known, value of voltage is given, so you can easily find the magnitude of current. So current I is equal to E by Z. Value of voltage is given, which is 10 volt, angle is 0. Value of impedance is already found, which is 6.26 and angle is 37.016. Now you have to make the division. So for division we are prefer the polar form, and it is already given in a polar form. So just make the division of magnitude. So 10 divided by 6.26, your answer is 1.59, and 0 minus 37, so your answer is minus 37.016. So this is your current passing through the circuit. Now E is equal to I into Z according to Ohm's law, and ER, voltage across resistance, is equal to IR into ZR. So ER is equal to, magnitude of current is already known, which is 1.597 and angle is minus 37.06, and ZR is already given in the data, which is 5 and angle is 0. So multiplication is always prefer in polar form, and this is given in a polar form. So just make multiplication of two magnitudes. So 5 into 1.597, so your answer is 7.984, and addition of two angles, so minus 37 plus 0, so your angle is minus 37. Now voltage across inductor, so it is denoted by EL, which is equal to IL into ZL. ZL will indicate that you have to consider only the inductive part. So magnitude of current is known, which is 1.59, angle minus 37, and XL, which is equal to 3.76, angle 90 degree. Make the multiplication of this two, so your answer is 6.023 and angle is 52.987. So this is the voltage across inductor. So now total voltage is equal to ER plus EL. So value of ER is already known, which is 7.984, angle minus 37, plus EL is equal to 6.023 volt and angle is 52.98. Make the addition of these two, so your answer is 10 angle 0. Now RC series circuit. We are assuming that one resistance and one capacitor is connected in series, and if you have to find the resultant voltage for this particular circuit, then how it will affect, that we have seen in this particular topic. Now the total voltage in a series RC circuit is given by this equation. VT means the total voltage is equal to under root of VC square plus VR square, where VT is equal to total voltage, VR is equal to voltage across resistance, and VC is equal to voltage across capacitor. So this is the phasor diagram. VR means the voltage across resistance. As we are discussed earlier, in resistive circuit, voltage and current both are in phase. So the phase difference of VR is always 0. VC is the voltage across capacitor. In last session we will discuss that when you are consider purely capacitive circuit, then the current is always leading by 90 degree, or you can say your voltage is always lagging by 90 degree. So VC have a angle of 90 degree and it is lagging by VR. So it is drawn like this. This downward VC will indicate that voltage is lagging behind the current. So this is your VR, this is your VC. Draw one line parallel to VR, second line parallel to VC, and join this. So it will give you the value of resultant voltage VT. It is very important to notice that the total voltage for a series RC circuit is not equal to the sum of the voltages across the resistance and capacitor. The sum of the voltages in a series RC circuit is always greater than the sum of the voltage across the resistive and capacitive component. Now impedance of series RC circuit. the impedance of a RC circuit is the total opposition to a AC current flow caused by the resistance and the reactance of the capacitor. It is the combination of R and XC, while in inductive circuit it is combination of R and XL. So the equation for the impedance of a series RC circuit is Z, which is equal to under root of XC square plus R square. For inductive circuit it is equal to XL square plus R square. Now Z is equal to total impedance in ohms, XC is the capacitive reactance in ohms, and R is the resistance in ohms. The impedance of a series RC circuit is always less than the sum of the values of resistance and reactance, because it is the algebraic sum, so it is always less than the actual sum. This is the vector representation. This is your resistance, which is always on the reference axis. This is your axis XC, which is always lagging by 90 degree, and addition of these two will give you the value of Z. So Z is the combination of R and XC for a RC series circuit. For RL series circuit it is R and XL in upward direction. So here it is your XC. If you are considering inductive circuit in upward direction, that is your XL. Now one more example is there. Resistor will offer 5 ohm of resistance to AC current regardless of frequency, while the capacitor will offer 26.5 to 8 ohm of reactance to AC current at 60 Hz. Find the impedance and current. The value of resistance is given to you and capacitor in ohms is given, so it is XC. XC is given to you and R is given to you. Frequency is also given to you. Now this is the given figure. R is equal to 5 ohm, C is equal to 100 microfarad, voltage is 10 volt and frequency is 60 Hz. Again we have to find the total impedance, which is equal to combination of resistance and capacitive reactance. So resistance is 5 ohm, capacitive reactance is already given, it is 26.5258. So your Z is equal to 5 plus 26.52, angle is minus 90 degree. We are considering XC, means it is capacitive reactance, so angle is minus 90. For inductive it is plus 90, for capacitive it is minus 90 degree. So your Z total is equal to 5 minus J, 26.52 ohm. Again Ohm's law for AC circuit is E is equal to IZ and I is equal to E by Z. Value of voltage is given, value of impedance is known, so you can easily find the magnitude of current. So I is equal to E by Z, voltage is given which is 10 volt, angle is 0, value of Z is known, it is 26.93 and angle is minus 79.329. So make the division of these two, 10 divided by 26.933, so your answer is 370.5 into 10 raised to minus 3. And 0 minus minus 79, so your angle is plus 79. So your answer is 375 milliampere, angle 79.325. Thank you. So in this session we will discuss about complex algebra, representation of alternating quantity by a complex quantity, how you can make the addition, subtraction, multiplication and division in a complex quantity for RL circuit and for RC circuit. In next session we will discuss about RLC circuit. If inductor, capacitor and resistance, all the three elements are present in the circuit, how it will affect and how you can find the total voltage for this circuit, that we are discussing in next sessions. Thank you.